So I'm Paul Coggin. I'm from Huntsville, Alabama. I'm an old school network guy. Got into networking, sysadmin back in '94. Got into routers in '97. Got into pen testing, doing network consulting in 1999.
Is it green?
Got it. Thank you. So I got into doing network security consulting in '99. If you've been through, suffered through any of my previous presentations, you know I like to tell war stories. That's my inspiration for my presentations. I go and see things real world, and I go and create a slide for them in their honor. So let's get started here. What we're going to get into in this conversation is layer 2 security problems that we're seeing out there. Everyone's focused on the upper layers of the OSI model, the web apps, using Burp Suite, Metasploit, which is all really good tools and it needs to be done. But when we go in and do audits and looking at networks, we're finding, I'm seeing anyway, that at layer 2, there is a ton of low-hanging fruit that's being missed. And all you have to do is go in and open up Wireshark, and you'll find just almost a dozen vulnerabilities. And a lot of them are Cat 1s. They're being totally missed. I was on an engagement. 3 different consulting firms came in and implemented 3 different manufacturing hardware, 3 huge different networks, and all 3 of those networks, 3 different vendors, 3 different consultants implementing, all had like 8 Cat 1s that were discovered with Wireshark. What was really bad, and what was a big inspiration for this presentation I want to get, is the guys who were doing the auditing and testing, OSCP, SANS, Microsoft, you name the certs, they had them all, have experience. We're wearing out the upper layers of the OSI model, web apps, systems, OS, vulnerabilities, but totally had missed the low-hanging fruit that was available in layer 2. I mean, because I personally went in and opened up Wireshark and had like 8 vulnerabilities on those 3 different networks, for example. We see this everywhere. So I want to make sure you guys that are out there doing pen testing that you're identifying these layer 2 problems. And if you're out there, if you're a defender, sysadmin, make sure that you work on this layer 2. And here's a strategy that I want to give you. Think about the control plane, the management plane, and the data plane. The control plane being the device-to-device communication. Your routers talking to routers, switches talking to switches. What are those protocols? What is your strategy for securing those? And in the management plane, how are you securing the management both in band and out of band? You know, your SSH, your SDP, or you're using terminal servers, KVM switches. How is that all being secured from the management plane? And lock down those trust relationships, and then the data plane, or the user traffic, which is typically the user traffic is what everybody's focusing on. But I want you to think about that control plane and management plane in your strategy, both, and look at it from both in-band and out-of-band, and do it for every layer of the OSI model, like your layer 1. What's going on with wireless? How could you go and attack the wireless infrastructure? How is the controllers being managed? Can you get the controller? Can you get the network management system that's managing the controller? And maybe the optical network, if you got a large optical network, up to your switches, your routers, etc. So here's some old school stuff. This arc poison. Everybody's focused on day zeros. We can't fix a day 30 years. It's pretty bad. They got all their systems patched, their Windows patched, they got their apps patched. They're regularly not, scanning their web apps, got all that automated. That you go in and they're totally missing the low-hanging fruit at layer 2, where you can go in and if you're not familiar with it, you can go in and do an ARP poison. ARP basically, if you want to go and connect to an IP address, your network, you're going to have to resolve your IP address to the MAC address. It's going to send out a broadcast, and whoever owns that IP address is going to respond with their MAC. Well, you can go and do an ARP poison by sending gratuitous ARPs, unsolicited ARPs, and poison the ARP cache of the network so that the traffic will be being redirected to you. This is some really old school stuff. ARP was created, 30 years ago? In most of the networks, you can go in and own faster, and you can boot your laptop using this. And you're not might not be able to pop Windows with the latest day 0 because they're all up to date and they're hardened and they got the whole space, firewalls, everything's all locked down. But you can go in and turn around and do a man-in-the-middle attack using a 30-year vulnerability because their network is not locked down. And here's an example of what it would look like using something like Cain enable. If I go and do this to a customer network, I like to use Cain enable because it's real nice for the PowerPoint. That's what at the end of the day, when you're out doing a pen test, that's what they want. It's all about the PowerPoint and the report. You guys are doing auditing. This slide is in honor of a guy. When you're out there doing auditing, no matter how many times they tell you they're doing SSH, they're going to they'll be sure and then we're doing SSH version 2. If you're out there doing audits, go and run this R poison against them, and then go and tell the network sysadmin, tell them that you think that one of their systems is hung up, and you might have accidentally DOSed it. And have somebody on the team have either EtherCap or Cain enable something fired up doing a man-in-the-middle attack, capture traffic and watch their reflex. What they do day to day, you will trigger their reflex. And a lot of times what you'll find is they'll go straight to telnet because that's the reflex. Because I did this to someone. I had a kid that never broke into anything. First thing I ever broke into, he did ARP poison Cain enable to the network guy. So I just went over and told him, hey, I think we hung up their Unix box. The guy immediately started telling him no. The day before when he was getting interviewed by the auditors, it was all SSH. But you can go and fix that. You can go fix this with like dynamic ARP inspection or IP source inspection. You need to get and make sure you got alerts for them. Now, something that at least once a year, when I was doing consulting, once a year get brought in and do incident response, and somebody is getting popped with a real DHCP server. It's like, oh my God. At least once or twice a year we're getting this. You need to go into those, if you got these managed switches, you've got the features there and the knobs there to lock this down. Go and lock down that trust relationship and don't let those end user access ports be spoofing the DHCP server and setting up a man-in-the-middle attack by advertising themselves as the default gateway. And what typically happens, how you're going to discover that this attack is happening to you, is that whoever it is that's firing up the DHCP server, they don't really understand networking and hacking. They haven't thought their strategy all the way through. And what will happen, they'll cause a denial of service because they forgot to turn on IP forwarding. So they'll hand out the bad gateway, get the traffic redirected to them, and then they forget to forward the traffic out to true routers. So the traffic's getting dropped in the bit bucket, and then the network guys start doing the Keystone Cops maneuver, and they end up eventually maybe tracking down whose rogue DHCP server is. So if you're going to go do this against somebody, make sure that you turn on IP forwarding, because this is how everybody gets busted. Otherwise, if they turn on IP forwarding, they'd never get caught, because they're not monitoring for rogue DHCP servers. Now, speaking of DHCP, I come from a background. I spent many years building telco service providers, fiber to the home, DSL, cable. And one of the things that we have to do in the cable service provider arena is provide the ability for law enforcement to come in and do a wiretap. You better believe that your ISP, when law enforcement comes in and they want your data, and they serve them with a warrant, they can tap your network. They can see all your traffic. They don't trust the cloud. If it needs to be private, you better be encrypting it. Somebody can be looking at it because the infrastructure is there. I'll put it in a lot of the networks. So here's what something I want you to do. A trick. If you're working in a network, you're doing DHCP, or you're working in a network where there are personalities that are totally against DHCP because they want to be able to track down a user more easily. Well, here's the solution for it. In the service provider world, we use a thing called option 82. So when the feds show up with a warrant and they want to know who has this IP address, well, we can go back into the logs and can tell at what time someone did a DHCP request and trace them all the way back to the individual physical interfaces that come onto the network. Because how this works is when you're going to send a DHCP request from wherever you get into the network, whether you're coming on wireless, fiber to the home, cable, what have you, when you come in, it's going to inject into that DHCP request header, it's going to inject in the chassis name and the physical interface that you're coming on the network from. And then if you have a DHCP server that supports option 82 logging, it will log that. So not only do you have the MAC address, IP address mapping, but now you have the physical name of the chassis of say the DSL DSLAM or CM capable termination system, the CMTS, whatever they came on the network. You know what physical network they were attached to all the way down to the interface. And so that way the feds can go kick in the right door to them. But the trick is from the enterprise side, a lot of us enterprise people don't know about this option 82. The new version of Microsoft's DHCP server supports option 82. Used to you'd have to go use like a Linux DHCP server or go get a more commercial robust DHCP server to get the option 82, but Microsoft's DHCP server supports option 82 now. So this is something you guys should be taking advantage of to help trace things back. From a blue team standpoint, I want to make sure you're aware of that. Here's some more old school stuff. It's out there, spanning tree. This goes back to that control plane. Why should your end users be seeing your network device traffic? They're sitting in their VLANs and they want to be surfing the web and getting your enterprise mission applications. Why do they need to be seeing network device traffic? Traffic from your routers, traffic from your switches, those switch-to-switch protocols, router-to-router protocols. There's no reason for them to see that. And here's one here that they should not see, the spanning tree. If you go back to your home network, or if you're out doing consulting and audits, you should pull that Wireshark and see what you're seeing and identify these protocols. Are they, like a spanning tree? No. Because unless your end users are running a switch, why would they need to see that? Because if you can see it, you can interact with it. You can interact with it, you might be able to manipulate and influence the network. And what you're going to see typically, if you're in a Cisco network, I'm an old school Cisco guy, you'll see a span tree protocol be spewed out on the wire, and what you'll see is DPU frames. You're going to see DPU frames every 2 seconds being sent on the wire. And typically, by default, you're going to see a default priority of 32.768. The lowest priority is what becomes what they call the root bridge on the network, where it can go in and calculate the span tree algorithm and determine the path through the network. But there's no reason for the user to see that. Typically, a lot of you guys probably turn on port fast, where you disable span tree on the end user access ports to disable that. But in case you don't do that, what somebody could do is they could come in and plug in. What if someone goes and plugs in a laptop and they got 2 NICs and they're able to get to 2 different places on the network? Maybe they could go and do a man in the middle at layer 2. I've personally never seen this type of attack. It's theoretically possible. Never done it because you would have to know a lot more about the target's network to be able to get yourself put into 2 different switches on the network. But what I typically see is one link into the network and a denial of service when this is attacked. And most of the time, when the span tree is attacked, it's not someone that's doing it on purpose, because an auditor or a pen tester is not going to do this on purpose, because this would be bad form, because you're probably going to cause a denial of service attack, which will stop your engagement, and your project manager will not appreciate that. When you stop, then the clock stops on the billing, and that's a negative. Then you got to find somewhere to put your time after that engagement. So you're typically not going to do this in the engagement. It's going to be typically what you're going to see where this attack is going to happen is going to be a user is going to bring in a rogue device, say their switch / router / access point / toaster microwave device that they picked up somewhere. And they're going to plug in, and I showed you on that previous slide, that priority of 32.768. What if they plug in their toaster oven router access point switch Internet of Things box, and it's a switch. It's running span tree, and it has a lower priority. It doesn't care that you've paid a couple $100,000 for some big Juniper Cisco switch in your data center, and it's supposed to be really rich. If you haven't secured your network, that $50 switch, or $5 switch they got off of eBay, you turn around and send all your traffic around, this got a lower span tree protocol. in Sweeter Tractor. I've personally seen a large manufacturing operation get knocked out because of that. Very large operation. They're running around like Keystone Cop, and then they're calling, just bringing in consultants to help troubleshoot the network. It's great for consultants, you know. But it shouldn't happen, because this is some old school stuff. Why are we paying all this money for the more expensive managed blinky lights? Pick your vendor Kool-Aid. Why are we paying for all that if we're not going to use the features that we bought? So we need to be looking at, so like I said, I'm a Cisco guy, so I know how to go and implement things for Cisco. What I implement for you to do on your Cisco stuff is you turn on that port fast on those end users, so they shouldn't be seeing any spam tree protocol. But go and turn on root guards so that you hard set who's going to be your root switches in the network. And also set up BPU guards so that if a user starts sending BPU frames on the network, then it'll shut that port down. And then they can call the help desk, and then they can explain why they're introducing span tree protocol into the network. Because it could be that maybe you've got some kid that's gone to Barnes & Noble and bought him a hacking book, and he's discovered a tool called Yersinia. Maybe he's introducing Yersinia. He's using Yersinia in, say, a VM or booting off of a Kali Linux CD and introducing these BPU frames. If you haven't played with Yersinia is pure evil layer 2. You can torment a network guy. He'll never see it coming. He'll never see it coming. Only do it. I recommend being complicated. Only do it if you have a signed get out of jail letter. You know, it's just like your rules of engagement. Because your Yersinia will DOS the network. You just totally torment the network guy. It's pure evil. It's pure evil. So here's another problem we see out there is there's this protocol called dynamic trunking protocol. Now I am adamantly against defaults. I saw a gentleman, really nice guy. I was there to do a network audit for him. I was not there to work on the network. I was just there to do some compliance auditing. Had this huge network. The guy had switches big as that door back there. You know, big, tall chassis, top of the line switches. Network ran like a dog because he had default settings set them and it getting errors. So it ended up losing his job, even though I fixed the network for him while I was there. So in this case, that story, he was had auto negotiation set on for his speed and duplex, and he was getting all kinds of CRC errors. He was killing his connections to the AS400, and so and making the web run really slow because he had defaults set. But here's another example of defaults that's going to get you hacked. Is leaving on the dynamic trunking so that your switch ports automatically negotiate. Why would your end users, kind of like the span tree, why does the end user need to see span tree protocol when they're not a freaking switch? Same thing here. Why is your end user be able to negotiate trunking and be able to multiplex numerous VLANs to get themselves into, say, the server VLAN, the voice VLAN, maybe your video surveillance VLAN, your Internet of Things VLAN? You know, for security, we got VLANs. We got segmentation. Well, if you left dynamic trunking protocol on, I'm going to jump into all those secure VLANs possibly. Again, our friend Yersinia can craft packets real easy if you're not into Scampi and rolling your own tools. You can just go download Yersinia, go down and use Kali, and jump into other VLANs and start influencing things. So we want to make sure that we lock this down. And so here's another thing to think about is being able to do VLAN hopping. And again, our friend Yersinia will do this for you, where maybe we've gotten dropped into a VLAN. Our users, say, or say in VLAN 10, for example, but we know that the good stuff is in VLAN 40, or we've got a user that's pissed off. He knows he's about to be fired. And he wants to disrupt, say, manufacturing operations. Well, it could be real easy that they could go and double tag a Ethernet frame and spike it down the wire, and that switch is going to see that, and it's going to strip off that first frame, and then it's going to have that second VLAN tag, and it could go and maybe drop it into another VLAN, say VLAN 40 here, and send it on all its way. Now, I would too, some of this layer 2 stuff we're getting into, you got to be real careful, make sure it's in your rules of engagement, because if you mess it up, you start causing adults, it's going to be time out. Because my goal is always to never make the help desk light up. Because as soon as you sign a contract to go do a pen test, you have not got off the elevator into your car yet, and the printer runs out of toner, and it's your fault. I'm not exaggerating. I'm saying, I'm thinking of a publicly traded company. We literally, they just got the contract signed, and we're getting blamed for things. Dude, we didn't even started yet. We just walked out of the conference room.
We got started yet?
No, we did not knock out your printers. We haven't even got back to Huntsville yet.
Not even told about.
It's like, true story. But these are things that we should be auditing. These are things that you may not go and execute, but we need to be auditing against and document when we give our customer report for due diligence, because it still needs to be fixed. Here's another problem doing blowing up the cam table. I would never do this during any engagement, but you need to go and audit their switches to make sure that they're protected against this. Go and look at their configs, make sure that they've limited the number of MACs per access port. Now, they're going to need more than one, typically, especially today. You're going to need more than one MAC address because you might have virtual machines, you might have voice over IP phones, things like that are plugged in. But there's no reason to have enough MAC addresses to even blow up the cam table of the switch. So we want to go and lock that down. And if somebody starts trying to blow up the cam table, we want to be to alert to that. Now, here's an old school problem. You guys that do, if you're working in an environment, Cisco, if you're not familiar with it, you need to know about it because this will bite you, this VLAN trumping protocol. You haven't done networking until you've been bit by this one. So in the old school way, when I first got into programming VLANs, switches, what you do is you would go in and specify a switch that's going to be your server, and then you figure out which ones are going to be your clients, and then you might have a case where you have one that's transparent. You typically you create all your VLANs on the switch at your server, and they would propagate out to your client switches. That way you can program the network from one place. And then on the transparent, what's happening with the transparent is standing alone. You can set it up the trunk and pass your VLANs across from switch to switch, but you're going to program each individual transparent switch. And this works really great, so everything's cool, except for the problem with most people go and use passwords like Cisco, Sanfran, or nothing on their switch, which leads to this nice little problem. And every time I go and talk to people at conferences and things, they tell me that there's always somebody comes and tells me they got burnt by this. So what you got to look for is what's going to happen. And I've seen this since I was working as a consultant since '99. I've seen this a lot. It's kind of like DHCP. Like once or twice a year, I'm going to see this, and somebody's going to call while they're on the phone with me updating their resume because they don't have a backup of their switch. You want to know if I know anybody's hiring. No, by the way, can you come help us rebuild our network? So what's going to happen here is this EGP server would have all their VLANs. Their documentation, they spilled Coke on that napkin and had the network drawing with the pizza stains on it. Because that's what's up to date. There you go, easier PowerPoint drawing is up to date. And so they got this, large network, large operations, and somebody decides to go and buy some gray market equipment, or they got some equipment that's sitting in the lab that's being used, and they need to add switch ports for a new project, what have you. And they go take this new switch, plug it in the network. They've left their BTP domain and their passwords all in default. This guy maybe sitting in the lab, what have you. It has a newer version of the BTP database. They go plug this bad boy in. It's because it's got a newer version of the database than what was in production originally. And it's set at all the defaults, which is to be a server. It's going to sync up and it's going to override your VLAN database. The help desk light's going to light up. you've never met the CEO, you'll meet the CEO that day. He'll know who you are. Don't worry, because the CIO is going to push you in front of that bus. This is real raw. Here's a true story. I'm going to tell you the names. Protect me from getting sued. So what we need to do is very simple. You guys that have gone, that are working with these devices, you go in, you do your show run, you do your show starts. You need to remember that the router switch config, your switch config, is not where the VLANs are created and set up. So you need to go and delete that VLAN.dat file, make that go away, and change your passwords. I'm about to run out of time, so let me run through this real quick. This broadcast storm, this is highly overlooked. All the network guys are overlooking, hardening the network for broadcast storms. There was a nuclear plant very close to where I live, so it's right here in my head. Is that on the news? They had an emergency shutdown a few years ago because of what appeared to be some kind of hardware failure on the network, which to me equates to broadcast storm. Again, we've got the fancy lights. We need to be turning on the broadcast, controlling broadcasting multicast storms, locking the network down. And whoever's doing the auditing needs to make sure this is done. Our networks today should not be getting knocked out by a bad NIC card. Seriously, this is something you guys are seeing a whole lot still. You plug in, you open up Wireshark, and this is low-hanging fruit. You're seeing the HSRP, the VRP, the redundancy, where you got two routers. They're sending a heartbeat between each other. One of the routers fails, the other one picks up. Well, here's what you're going to see. You're going to see these two routers talking to each other, and you're going to see the password and the clear. Typically, it's going to be like Cisco or Samsung. I mean, this is no joke. Even though they could do like MD5, they will not. They will either have no authentication or clear text. I kid you not. And don't think it's just an HSRP Cisco problem. VRP. I saw two other. I saw this on a Brocade and Juniper network with VRP. So what we can do, we can import those packets. We can import those packets into this tool, Colasalt. Now, some of you guys are into Scampi. If your Windows impaired, you want something quick and dirty, download Capsule Colasalt, import the packet. You can go in and edit any of the fields, rebuild the checksum, and fire it on the network. This is a cool little tool, and now you're a router. Sure. You just change the IP address to your IP address, you take it, and now you're a freaking router. But remember what I told you about the DHCP guy. Remember to turn on IP forwarding, otherwise you're going to be dropping traffic in the bit bucket. And then V6. A lot of people are running V6 and they say they're not, but they really are. You can go in and look up 86DE or just type in IPv6 and filter all of IPv6 traffic. You're going to be seeing router solicitations where they're looking for a router so they can learn their IPv6 IP address. You could go in and start acting like a router. This is going to replace there's no longer R poisoning with IPv6. This is your replacement for R poison doing spoofing the router in your LAN so that you can do a man-in-the-middle attack. Similarly, again, R poison is gone, but with IPv6, we got the network discovery spoofing we can do because they're going to be sending out discovery out in the VLAN trying to discover their IPv6 peers. But it's all because it's multicast. We don't have broadcast with IPv6, we have multicast. So we can go and spoof network discovery protocols. And the tools I would look at doing instead of the Canaan A1 EtherCap that we all learned years ago, look at Chiron and Evil Foca. Chiron's really good. And some of the DMZ stuff, we need to go back again, layer 2. Look at putting private VLANs in place, VLAN access lists. Lock down these DMZs, those trust relationships. If you got a network that or switches, you got politics you can't deal with, that's hard to fight, go and look at maybe NSX, implement NSX. NSX is really good. If your network infrastructure doesn't support segmentation and locking down the layer 2, layer 3. And again, on monitoring, I'll wrap up with this. With the monitoring, you got to get visualization on the network. I recommend you put taps in place, because what if somebody hacks the network infrastructure? What if the router switch guy goes rogue? If you're a large enough network where you need separation of duties, put in network taps and send the traffic out of band. Because I can tell you as a router guy, I don't want security guys in my network. I'm a router guy, I'm a router. I don't need anybody helping manage the router. So put in taps so you remove all the politics. You can put it in an out-of-band network to monitor. So here's some references from where this is where I learned everything. EnoRay, the Landscape Security Book from American Yvonne. The router security strategies is good. So over time here, I believe. You got time for questions?
We have a microphone because if you're going to be on the stream, they can't hear you. And please repeat questions.
Okay. Any questions?
I'll throw one out, I guess, if no one has one. So this is all very enterprising, which is good. How does this translate to, say, when folks are deploying onto AWS or any of the cloud environments and you have virtual private networks and the traffic is passed conceptually in a similar fashion? How do you see that the lessons learned here can translate to the world where there is no physical switch?
I personally have not dealt with AWS or the cloud services. If I'm going to buy the service, I'm going to have some kind of a management plane that I can use to go in and lock down my trust relationship. But my understanding is you can go in and buy virtual firewalls, et cetera, and lock down the data plane. You should be so. I would recommend you go and build a traffic matrix of what those trust relationships are going to be, so that you can lock that down. Depending on what the cloud vendor is, you can go there. I'd have me a traffic matrix defined and use whatever tools they make available to you to lock down those trust relationships.
On a napkin?
Why you have a pizza?
Well, yes. Fence in depth and separation of duties. Thank you. Anyone else?